The recording in a second. I will share the screen. I just want to make an introduction before I start. First, about yesterday, I rendered the video with the cuts because I forgot to turn it off during the break. So there was a hole of about 1 hour and 15 minutes, and I am uploading it today. So it should be available when we meet again in the afternoon. So what is the purpose of the lecture today? Today, it is a lecture, as you know, about the lab, and I would like to try a challenge, actually, because the target of today's lecture is to instruct you how to run your own climate model. And you know that we talked a lot about climate models, predictions by climate models, and we also learned how to download the data because Ray instructed you how to get the data from the Copernicus data store or other sources. And indeed, these data are produced by models, which basically you learned how they work. And a very good question is whether these models can be run by ourselves. Of course, usually we don't need to do that. We don't need to autonomously produce the data. Or usually in our engineering application, we rely on data produced by others and data that are available. But on the other hand, learning how to run a model is interesting for two reasons. First, if you run a model, even if you use a model that of course has been built by others, you learn some more about the model itself, because if you want to install it on your PC, if you want to run it, if you want to see the results, of course, you need to learn also something about the structure of the model. So this is why I think this is interesting. And, learning more about the model for an engineer is important, because we said many times that we shouldn't really use tools without knowing, or results from tools without knowing what is behind the results. So it is indeed interesting to try to learn some more. And second, you may have the opportunity or the need to produce, at least for a very small location, not at the global level, but for a very small location, your own data, because you may want to include some additional features, like you may want to increase the resolution. Because if you download the data from the Copernicus data store, they have a coarse resolution, maybe 25 kilometers. You may want to reduce it. And this is one of the reasons. Second, you may also want to modify the model. And this is more challenging. This is not usually done by an engineer. But indeed, if you have the model on your PC, you can also play with it in some ways. And I give you an example. I worked recently with the national body that is managing the railways in Italy. And they told me that they ran indeed their own climate model because they wanted to study the probability of flooding of a branch of the railway network in Italy. So they had this piece of the network, this relatively short branch that was flooded, and they wanted to see if in the future this risk of flooding was going to increase. And they told me we run our own climate model. And actually, I never tried up to a couple of months ago to run my own climate model. So I asked them, but how did you do that? And they said, yeah, it's relatively simple. They explained to me and I explained to you, if you simulate only a small region, then the model can run on your own PC, because you need big computational requirements when you want to simulate at the global level, and then you need supercomputers, otherwise it takes years. But they told me, if you simulate over a small region, then you can run your own model, and on the web you have all the data that you need to do that, including information on the land cover, on altitude, and so that you can estimate the orographic effects. And they told me you can also simulate convective processes if you go down to a resolution that is that typical of convective processes. So I became curious, and indeed I tried, and I realized that it's not so easy, but it is something possible. And therefore, my idea of trying to convey the message to the students. And so today, I built a web page explaining step by step how to do that. And today, I would like to try to explore with you this opportunity. As I said, it's a bit challenging. And when I tried to search for the information, first of all, I asked the colleagues of the national body for railway management to help me. But indeed, their help was okay. But they said, look, you have also to get information from the web because it's something intended for very evolved users. And indeed, it was a bit not so easy for me to find on the web the most simple way, the simplest way to get to target. So I tried to assemble the best information that I could, and I put it together in a file, and I tried to repeat the procedure on another PC. It was successful. So this is what I would like to propose to you today. I'm not assuming, and you don't have to do that you follow me on your PC. You just have today to follow me on my screen, because it takes some time to install the model and run it. Not really a huge time, but it may take like, when you run the installer, it may take half an hour, and we cannot stay half an hour waiting for the installer to finish. And second, there is to say that I'm working on a personal PC, but on a personal computer, but my computer is quite powerful. It's you already experienced on your PC that when you launch demanding tasks, this becomes a bit problematic. On the other hand, once that you know how to do that, and you have the video also, you may, for instance, preparing the thesis, you may want to get access to a workstation. And for instance, the university, when you prepare the thesis, can give you access to a workstation, and you can do that over a workstation. So I think anyway, the information is useful, but I anticipate that it is not really easy. And I also anticipate that you don't have to be concerned if some of the steps look not clear to you. I mean, there is the guidance, you can repeat it if you are interested. If you are not interested, I think it's just enough to know that you can do that. And it is also doable on a portable PC, provided it's a PC with some memory and not an old one, let's say. So it's just enough, if you are not really interested in an application, that you know that it can be done. And in case you are interested, instead, you can indeed try to repeat it, and not on your own PC, but by applying for access to some computational facilities. And in the university, this is possible. Okay, so let's then try to repeat it. And another thing, of course, I will give you step by step the procedure, and you don't have to assume that you understand fully what is behind it, and you understand fully how the model works. For today, you just have to look at the steps, and knowing that you can get more details if you need them. This is also valid for me. Keep in mind that as I said, I started a couple of months ago, and there are some steps of this procedure that I am suggesting that are also not clear to me. Also, you are like our guinea pig today, and also myself, meaning that you will see the web page, and some of the steps may be not clear. So if you have any suggestion, just let me know. Okay, and I also expecting to find some needs for editing in the web page. So I am also keeping open, not visible to you, the page to edit it. So we can also correct online while we move forward. Okay, let me share my screen, and before I share the screen, let me start. Sorry, VirtualBox, I forgot to do that. And VirtualBox, you know what it is, because what I would like to do is to install the model on a virtual machine, not really on my PC. I'll explain you why. So let me start VirtualBox. This is perfect, and let me start the virtual machine. Okay. So, okay, very good. 1 second. Full screen. Okay. Now I'm ready to share the screen. So let me share it. I can share this one. I think you should see my screen, and here you should see the web page of our lecture notes for the lab. And if you don't see it, just let me know, okay? And here in these links, you don't see the links that Ray provided to you. So just beware. I may ask him to give me the link and include them here, but for now, beware that this refers only to my part. So now you can see here running your own climate model. Let's click on it. And this is the web page that is brand new, and which explains, as I said, step by step what we do. First, there is the description of the model that we will apply. And in particular, it's called WRF, which means whether, I don't remember the meaning of the acronym, but we will get to it. Let's open the link. Let's open the link, and yeah, it is Weather Research and Forecasting Model, WRF. It's produced, it is a community effort, but it's produced by a governmental agency in the US, which is the National Center for Atmospheric Research, NCAR. And here there is an explanation of the model, downloads, you see, and source code, graphic software, and etc. And the documentation is very extended, and therefore, I mean, it's, as I said, it's a huge documentation. There is here a user page, and if you go here, this is interesting because it gives to you a lot of information. And there is, you see here, general information page, users on page, and then there is the model overview, and there is a lot of documentation. I didn't study all of it, of course, because as I said, it's very extended. User support, and there is also the download page here, etc. So a lot of information, as I said. But now let's close this and go back to our web page. Here there is a disclaimer which says that I am a non-expert in climate modeling. The tutorial was compiled by assembling several sources of information for teaching purposes. It's not written here, but it is for teaching purposes to engineering students. So the tutorial is relatively short and doesn't provide, as I said earlier, all the information about the model and about many things. There is an introduction to global climate models, which we already discussed, but I just want to summarize why the discussion is here. Because as we will see, this, as I anticipated, this WRF model is not a global model. It's a regional model. I mean, it is meant to be applied on a limited domain. And it can be applied also at the global level, but usually it is not. Usually at the global level, we apply other models. This has been conceived for being applied at the regional scale. And if you apply a model to the regional scale, you need boundary conditions. You need initial conditions, like for a global model, but you also need the boundary conditions, because of course you refer to a limited region, not the whole globe, and therefore you have to give the boundary fluxes getting into this region, like the fluxes of water vapor, etc. And these are the boundary conditions. And the boundary conditions, they have to be provided along the whole duration of the simulation, not just at the beginning. At the beginning, it's the initial condition. But the boundary condition have to be provided for the whole duration of the simulation. So it means that the regional model, strictly speaking, it cannot run autonomously, independently of by itself. It needs these boundary conditions that have to be provided by a global model. So WRF is conceived to receive boundary conditions and initial conditions from a global model. And this is why here there is a premise on the global climate models. Of course, the resolution of the global model is larger with respect to the resolution of adopted in WRF. So we apply WRF because we want a finer resolution. Otherwise, we would use the output from the global model. So the question here is that I have indeed, before applying WRF, I have to download information, predictions from a global model, and maybe the Copernicus data store, etc. So you understand that we have to download a lot of information, because even if the domain is reduced, the information that I need to download is quite important, and this information has to be given to WRF as input data. And again, it's something that is not relatively, is not so easy, okay? And so basically here there is a discussion of global models, but you already know it, and you see the limitation. Resolution is coarse compared to local weather. So basically, a typical CMIP6 global model grid is about 1 kilometer resolution, 1 kilometer by 1 kilometer, the size of the grid. So it's 10,000 square kilometers. And while WRF can run over a resolution of 1 by 1, for instance. So let's see something more for WRF. WRF, I am quoting from the website. Just 1 second, because I need to correct here, quoting from the WRF website. WRF website. Okay. Is a state-of-the-art mesoscale numerical weather prediction system. So it can be also used, and it's typically used for meteorological prediction. So many meteorological services rely on WRF. They take the prediction from the global climate model and they run WRF at a final resolution to produce the weather forecasting. Of course, it can also used to run a simulation of future weather, so it becomes future climate if the simulation is extended for at least 30 years. And WRF is also used often to downscale, as I said, the simulation from global climate models, and also to downscale historical data. So WRF is also used by taking observed data, so observed climatic variables, observed at a large resolution, because we don't have measuring balloons, we don't have weather stations everywhere, and therefore these data are collected, and then they use WRF to downscale this historical observation at the grid scale, okay? And so it is a model that, being a regional weather climate model, can be used for several different purposes. So here there is a brief history. The effort began in the latter 1990s and was a collaborative partnership of the National Center for Atmospheric Research, NCAR, the National Oceanic and Atmospheric Administration, and the Earth System Research Laboratory, the US Air Force, etc., etc. It is indeed a nice opportunity. I mean, the fact that these administrations provided this ready-to-use climate model, it's indeed, I mean, a commendable effort. And also we have some global models that are publicly available, which, however, we cannot install on our PC. Once again, WRF can be used as a global model. Of course, you have to modify it a little bit to remove the requirement for the boundary conditions. It can be, anyway, be used also at the global level, but usually people don't do that. Usually people at the global level, they use other models like the ECMWF model, and there are also some models produced in Italy and run in Italy by the by the CMCC, which is the Euro-Mediterranean Center for Climate Studies. And a model that is frequently used is the community climate system model. Here there is a link, which now we open, but again by NCAR. And here is the website. We don't go into the details, but just wanted to inform you that this effort to produce open source softwares, it's a commendable effort and makes available both global model and regional models. Once again, if you have something to say, let me see in the chat. If you have something to say, please step in with the micro, because I don't see automatically the chat, okay? And I hope that you are following me, but in any case, if you have some problems in following, please step in, okay? Good. So this is WRF, and again, you can refer to the website if you want more details, but now let's move forward to the installation on our PC. This is a figure that is taken by the WRF website, and it's a simulation of the Hurricane Rita. And you see here, you can recognize the United States, the East Coast, and this is produced indeed by WRF. So it's a powerful modeling system. Okay, so let's now try, as I said, let's discuss installation. So I decided to explain how to install it on a virtual machine. Actually, the procedure is precisely the same. So the only difference is that if you want it on a virtual machine, you have to first install the virtual machine. Why I preferred to refer to the virtual machine? Because WRF needs Linux to be run. Needs Linux because the instructions have been developed for Linux. You can find a lot of support. I think in principle it can run under Windows, but it's much better, and if you have a Linux operating system behind this attempt to install the model. And also the reason is that Linux is much more efficient in computational terms. So these global models, they run under a Linux environment or a similar one. Okay, if it's not Linux, it's a similar one, and they usually don't run under Windows. However, it's not a big problem because we already tried to install a virtual machine on our PC, and I assume that you were successful in doing that. And we learned that it may take some time, the installation, if the machine is not, if the host machine is not very powerful, if your PC is not very powerful, it takes some time. So what I did is precisely on my PC, from which I am teaching you today, to install a virtual machine. And I did the same procedure that we did together. And let me just show you the screen of my virtual machine, because I will jump here and there when, just one second, Okay, perfect. Here and there while I'm teaching. So let me see. So this is the screen of my virtual machine, and it is a brand new installation. I just installed it 3 days ago, and then I installed WRF over it. But it's a brand new installation, and as it is described in my website, let me delete this. As I described in my website, I took Ubuntu because I wanted to make the same procedure that we did together, which you already know. I took the minimal desktop of Ubuntu, so no additional software loaded at the start, at the creation of the virtual machine. So minimal desktop again, and then that's it. And then you can see here Firefox as a web browser, because I installed it because I needed a web browser, because of course I wanted to make the cut and paste from my web page to the virtual machine, so I needed the web browser. And in your default installation, you have also File Manager. I use that. It's this one. And I didn't install any other software. So it is really a brand new one, like yours. And if you had a powerful PC, you could just install WRF. Okay. So let's now go back to the other screen, this one, and let me go here. Okay, so here I explain why Linux, and the reason is computational requirements, and then here there is an explanation on how to install the virtual machine. You already know it, and I put this screenshot because I wanted to give you an idea of the size of the virtual machine. The first trial that I made was to install WRF on a virtual machine with a hard disk size of 12 gigabytes. Unfortunately, I ended up with no space left, and therefore I created a virtual machine with 50 gigabytes hard disk. I think it is more than enough. Let me just see in my current installation. Actually, yeah, I have only 50 gigabytes are needed. I think it's much better to increase it because it looks like I don't have much free space indeed. Let me just see. I want to make another attempt to, yeah, it is indeed almost full. So let me just, I will edit here and I will write that it's much better to take a larger hard disk. So let me just edit here. And this is 50. So some more space is recommended. Okay. And then I gave 8 gigabytes of memory and 4 processors. I think should work even with less than 4. In my PC, it's a modern one. I had many processors, and therefore I opted for 4. But I think it can work also with less than that. Okay, now this is the recommendation, and then I installed this Ubuntu. I selected safe graphics, but I think I could have also choose try or install, which is more or less the same thing. You already know how to install it, so I'm not taking any more time on this. And then I installed Firefox with this instruction because, as I said, I needed a browser. By default, if you take the minimal desktop, it doesn't have any browser installed. So I installed the Firefox, which was okay, and I think it's okay. But you can also install Google. It's not really, doesn't matter. And then I I said launch Firefox and then open the present page so you can copy the commands below. Now, installation of WRF. First of all, a few words about the structure of the model. The structure of the model is divided into blocks, and in particular, there are two separate programs that you need to run anytime you want to make a simulation. So you have some external data sources, as you see in the figure on the left, and these are static geographical data, because you need the altitude, as I said, you need information on several features of your domain. And it's also nice because when you select a domain, you can get also a picture as an output of the altimetry or other information. And these are static data, meaning that they are fixed. And then there are gridded meteorological data, which are initial and boundary conditions. And these are gridded at the size of the global model. So when you get them from the global model, you get this gridded data on a grid size of, for instance, 100 by 100 kilometers. Then you need to pre-process this data through what is called the WPS. WPS is, the acronym comes from W of WRF, pre-processing, P, system, S. So it is a pre-processing because from the size resolution, from the resolution of the global model, you need to basically bring this data through a simple interpolation to the resolution which you desire for WRF. And therefore, this preprocessing is essentially an interpolation scheme, which, however, it is quite complicated, but it's very fast, actually. And then you produce the input to the WRF model. And the WRF model, to run the simulation, you have to start two routines. One is called real, we will see the details later, and one is the actual run of the model, WRF. The first one is a kind of additional preprocessing, and it's very fast. The second one can take a very long time, and we will see some more details on the timing of the simulation. This figure refers to a real case, so the preprocessing of the data or the preparation of the input data refers to the situation where you get meteorological data and gridded data from global models. WRF can also run idealized cases, so you can produce yourself your initial and boundary condition, and then run an ideal case. In this situation, in this option, you need to run a different first routine, not the real one, but the ideal one. Okay, but for now, let's focus on the real one. And indeed, this tutorial is conceived for telling you how to perform real simulations. Now, how to install WRF? Actually, I found a script, and I found it not on the WRF website, but I found it through my path along the web. A script that automates, make everything automatic. So it is really straightforward. I already launched it 3 times and worked on different PC. It is amazing because if you look instead at the WRF website, the installation procedure is quite complicated. You first need to install in the PC several software that you need to run the model. So there is a preliminary preparation which consists of installing libraries. These are additional softwares that you need. It's quite complicated. I initially tried it, and even if I am Linux users, you know, in compiling source codes, I am not so good because it is something that I don't frequently do. And therefore, you know, when I found the install script, I was very delighted. So here below, I suggest to follow the script. You know, for getting a ready-to-use solution, we suggest to refer to the installation script by Umurdink, which installs the needed libraries. The script is written for Debian and Ubuntu-based Linux operating systems and is conceived to run on a freshly installed operating system. As I said, I used it twice, now 3 times. It got to target successfully in all cases, but note that the installation takes a long time. What do I mean for long time? Like 1 hour, okay, not days. But on this virtual machine, which I created with the features that you know, it took about 1 hour. Now, what we have to do, we need to download the installation files, and this is, oh, sorry, not really. Now we just need to download the install, okay? And where to download the install, I show you in a moment. And then we have to launch it on a terminal with this instruction, which is repeated on my website. Where to download the file? Here you have the zip and the tar. I suggest to download the tar because given that you have a freshly installed Linux machine, if you want to expand, extract a zip file, you need to install an extractor. While if you download the tar, the extractor is already included in the default freshly installed machine. So basically what I did is, and let's go back here, I downloaded it, and then I extracted the file at the terminal with the command tar, the command that you see here. And why your version? Because, as you see, there are continuously new versions, and therefore now here you have the instructions for installing WRF 461. But as you see, there are here instructions also for the previous versions. So it depends on the versions that you download. So I didn't copy precisely this instruction here, but I copied this one, your version. In what follows, I just put the commands for the current version, which is 461. Just don't forget that if you select a new version, also here, you see here, this is the install for 460. Let me see. Yeah, I don't understand what's because I thought I installed the 461. I'm not really sure. I'll check later, okay? Because maybe that these are the commands copied from my previous installation. I think in the virtual machine I have the last one. And also, I think, let me just write here, I make a correction because I think this is, I need to correct it. Okay, perfect. Now, before launching the installer, you need to make it executable. I think I didn't write it here. Yeah. Let me just write it. Don't forget to make the installer executable. Automatic executable, I'll tell you in a second. It's basically what you need to do is just to do this. Let me go back to the virtual machine to make it executable. You have to, okay, let me share the virtual machine. Now there is the screensaver, just 1 second. I start a terminal, anyway we need it, terminal emulator, here it is. So let's suppose that you have a whatever file, you want to make it executable. The instruction is chmod, and then users plus executable, users plus x, and you put name file here. Okay, this is the instruction to make it executable. So for instance, probably I already have it here, but my history became quite long, so I don't think I can easily find it here. But I just wanted, oh, it looks like I indeed installed the 4.6.0. Maybe that the latest version came only recently, I'm not sure. Anyway, this is the tar, you see here, this is the tar file, the extraction of the tar file. And then I went into this directory, and strange enough, I don't see the instruction where I made it executable. Anyway, it's in any case, it may also be that when I downloaded it, it was already executable. And but in any case, just check. Okay. And if you run the instruction to make it executable and the file is already executable, it's no problem. It doesn't happen anything. Okay, now let me go back again to our screen. Okay, and it's 1 second. It's here. Perfect. Now. It's installed. After this long time, it downloads a lot of data, and then it's installed. Okay, here we see that indeed there are two classes of simulation. We can run it ideally for an ideal case, and then we can use real data. Here you see that the idealized simulation typically manufacture an initial condition file from an existing file. For instance, you may want to see what happens if you refer to a simulation of past climate and you change some of the initial conditions or some of the boundary conditions. Like you want to see in the flood that hit the Emilia-Romagna region in 2023, what would happen if the initial water content in the atmosphere was 10% more. So this is an example of an ideal case. The real data in state cases usually require pre-processing from the WPS package, we already mentioned it, which provides each atmospheric and static field with fidelity appropriate to the chosen grid resolution for the model. Okay, and the model executable is not altered by choosing one initialization option over another, but the preprocessor, yes, the preprocessor relies on the grid size that you gave, on your initialization option. And you see that there is a real exe program for a real exe means executable for running real cases, and an ideal exe program for running ideal cases. That's fine. Okay. And here, this is just copied from the website, and it doesn't say anything really applied, referred to our case. And so let's go straight to our simulation. This tells you how to run the model with an hypothetical simulation for January 24, 2000. Okay, let's move forward with our case, because I want to illustrate another case. In fact, I see we focus here on a real case, and then we need the data, the initial condition and boundary condition. And the starting point that I suggest for getting the data, you can get the data from ERA5 from several sources. The only thing is that you have to make sure that the data are downloaded in the format that can be digested by WPS, the preprocessor for the WRF model. So I prefer, for this example, to refer to this page of NCAR. And this is a web page, you see, available data sets from NCAR. And here you see that there are several data sets. You see the temporal resolution and the temporal availability. What I suggest is to refer to
we cannot see the website, and that is you say to us.
So you don't see it? Okay,
No,
let
no.
me see why. And let me share again the screen. Do you see it now? It's
Yes, but it's not visible.
it's not visible. What do you mean? So you don't see?
The resolution is very low.
Okay, okay.
Yeah.
I don't know how to. Let's see. I can try to increase the size, but
No. With increasing the size, we cannot see again.
okay. Okay, let me try to. My website, you see it, okay?
No.
No?
No.
But it was visible earlier, my website.
Yeah. It was visible.
Okay, so I think it's a problem with
Professor, you can check on the message box how it's being seen by us.
yeah, okay. I think it is a network problem. Let me see. What I can do is try to share. 1 second. I can try to share not the screen, but is it sorry? Is it better or not?
Yes, now it is clear.
Now it is clear. Okay, perfect. I changed an option. Okay, so what I visualized earlier was this one. Now, let me go back and let's go to this page, and which is the page of, just give it some time to, okay, it's the page that gives the data from the Geoscience Data Exchange, GDEX. I think this should be linked from the previous page. Here you see the previous page. Let me see. I think there should be a link here. Let me see. It's from, I don't see it here. Yeah, maybe it's a different source and it's not listed here. Here you have some options. You can also take these ones, but I refer to this. What is this? It is the Geoscience Data Exchange provides the initial and boundary condition for past climate, historical climate. And these data are derived not from model simulations, not from global model simulations, but are derived from observations, as I mentioned earlier, that are downscaled. Okay, and here you should look for. I go back to my website. You should search for this string, operational model global tropospheric analysis. So I copy this string, I go here and I make the search, And here we are, and we get several options, and we select this one, operational model, global tropospheric analysis, continuing from, no, not from July 99, but yeah, or yes, let me see. Yeah, I think I took this one. Let me just check, because in the website there is written in the search box. Okay, continuing from 99, perfect. So let's take it. This one, we click here. And then there are a lot of data that we can download, and to decide or to follow me what I did previously, let's look on my website. I go back, data access, sorry, it's here. I remember it. So now we can refer to, for instance, we may refer also to the first row, but I refer to the last one because I wanted to perform a simulation that was recent. So I refer to this, okay? And we need, I suggest to select web download. So we go here. And then file search or view. Let me see. I don't. We have to click on link, and I think no, it's not this one. I go back. It is the second one. Sorry. Data access, web download. This one, link. Yeah, and here you see for each year. What you see is 6 hourly files for 2007, and I downloaded this one, okay? And if you click here, just because it was the first one, so for the year 2007, of course, if you want that, or no, I think I took 2025. I took this one. If you want to a recent simulation, I took this one. So let's click over it. 1 second. And now you see for each month, you have the data. And you see that the data are until November. Actually, they are released a bit later. They are not released as soon as they are produced because they take some time for checking. So this is not ready to be used for weather forecasting, because you could also use, if you have the data, the initial condition for today, you could also use WRF to predict the weather in Bologna for tomorrow. It's like a meteorological model. But actually, these data are released with some delay, like a couple of days. We can see. Let's click over November, and you see that here for November, it's this one. This is 1st of November at midnight. You see where is the selection. You see it's 2025, 11 November, 1, first day of the month at 00. And then you have again 1st of November 6, 1st of November 12. They are issued every 6 hours. Let's look at the last one, when it was released. And let's go down. And you see 20th of November, actually it's already there, that of midnight. So, but actually, if you want to make the prediction for tomorrow, you would need also the predictions, because the boundary condition, if you want to simulate up to midnight today, you need the boundary condition up to midnight today. And here, what you can do is to simulate yesterday, but not today. Because if you want to simulate the 19 up to midnight, you need the boundary condition given by the last 5. So you see that there is some delay. And if you look in the website, it is explained why there is the delay, because they want to check. So if you wanted instead the predictions in order to make the prediction for tomorrow, of course, you need the boundary condition for tomorrow that are predicted by the global model, which is not observed data. So you shouldn't use this data if you want to make a prediction for tomorrow. These data are observed data, so you can use them if you want to simulate the weather of yesterday, but not for tomorrow. Okay. And if you asked me, so what kind of link should I follow to get the prediction for tomorrow? given by the global model, I didn't inspect it. So actually, at this time, I don't know. And this is something that you could explore if you are interested, okay? So what I did instead was to download. My idea was, let me go back. My idea was to perform a simulation for September 2025. And I choose September, so I go back, web download, link. I choose September because 2025, because when I started these attempts, it was a couple of months ago, and so September was the last one that I had available. So I clicked on September, and I downloaded, as it is explained in my guidelines in my website, I downloaded the first 4 because I wanted to perform a simulation from midnight of September 1st up to 6 p.m. of September 18 hours. So it was 6 p.m. of September 1st, 18 hours. I wanted to make a simulation of 18 hours. Why only 18 hours? Because otherwise it took too long, because I tried a longer simulation. Just to give you an idea, for 18 hours in a domain that you will see what is the size of the domain that I selected. It's around Bologna. It may be an extension in square kilometers of something like 60,000 square kilometers. No, sorry, I am wrong, not 60. It's about like 10,000 square kilometers. So it's quite a small domain. And for this domain, 18 hours, it took like half an hour to simulate it. So it is not really short, okay? But of course, if you have a slow PC, you could also perform a simulation for 2 hours, because it's not a problem. You can, just to try, you can also make only 1 hour. It's not a problem. I decided to make it for 18 hours, and then I downloaded the first 4 files, and I put them in the directory that is accessible to WRF. Let me explain where is this directory, and then I need to go back to the virtual machine. Let me share this screen and share the other one. So here I interrupt and I share the other one. Let me get the high quality, because, okay, now you should see the virtual machine. Let's forget about the terminal. Let me just go, and let me go to the file manager. Here is my home page, my own directory in the virtual machine. And after installation, you would see that a directory called build WRF has appeared. I launched the installation from the directory where I downloaded the file, and it created this directory under my home. So it's like a directory under your space in the virtual machine. And if you go into this directory, you see that there is a directory for WPS and a directory for WRF. There is a directory of libraries, there is a directory with geographical data, these are static data, and for the whole globe that are contained here. And there are also the original compressed files with the source code. I left them there, but you could remove them. And I created a directory called input data. This was created by me. It is explained in the website, where I put these 4 files that I downloaded. These files are binary files. Binary because they wanted to minimize the size of the file. They are data file, but instead of being provided like text file, they are binaries. And the format is what is called GRIB2. And you see the extension is GRIB2. It's a format that can be read by WPS, by the preprocessor. Anyway, you don't have to wonder about that. Just download the files, put them in a directory which I call the input data by following the instructions of some guidelines that found on the web, and it's explained again in my guidelines. You put them there. Okay, so let's go back to here. Okay, so we downloaded them. So let's close it and let's go back here.
It is again can be unclear.
Strange, because I selected the high resolution. Let me check again. Because it goes by default under low resolution, and I don't understand why it does that, but probably because HD. And let me try. How is now?
No. It is not clear.
I think it is a connection problem. Let me try to get a screen, a window other than the screen. The quality we can just take HD. And let's see how it is now.
No, Professor, it is not clear.
There is nothing that I can do. And what you can do is you open the web page under your PC. And you take as a reference what I'm showing over the screen. And but on the other hand, you read from your own PC. Because I think it's a connection problem. I don't have any other explanation. I can try again, but I don't think, because it goes by default in lower quality. Let's see. I try again, but I'm not very confident. How is now?
It's
Yes,
good
it
now.
is okay. It is
Okay,
okay.
let's see.
It just needs some refreshment. Maybe it's the internet connection.
Yeah, maybe. Okay, so you see that it's there is explained here what I just did, and here there is a screenshot from the website. We already saw it, and then the 4 files. Okay, from this one to this one, and then yeah, I forgot to do this. Let me just because. I need to reopen it because unfortunately I closed it. Okay. 1 second. Sorry. I need to reopen it because I forgot to data access, web download, link, and then let's take 2025, and then we are almost there. And 01, let's see. Okay, very good. So if I select these files to download, now what I have to do, let me see where it's get download Python download script. I think I have to go here. The link was above. Python download script. And you see that a download started. Let me open it. And let's open with the text editor. 1 second, because I need to open it from the file manager. Here we are, and I put it over the screen. So this is the file that I downloaded. It's a Python file for download that we need to launch into the terminal of the virtual machine. Okay, so basically, let's close it now, or let's keep it open for now. And here you see that there is Python download script, and here I copied the script. Okay. Then in the terminal we need to run this. Let's try. Okay. Let's try and let me share the other screen because I think it is interesting. 1 second. Now you see the virtual machine, and let's go to the terminal. It's here. Okay. Let's now try to run Python. Let me see, where is this file? I think it is. I don't remember where I put it. Let me just see. Start.py. Okay, there is no file here. Let's see if it is in download. Maybe I put it in download. So yeah, it is here. Okay, so let's try to launch it. So Python 3. Python is already installed in your virtual machine, so you don't have to make any preliminary installation. And I don't remember. Yeah, this is the file. If I launch it, you see that it's downloading. So the download started. It's very simple. Okay. And it's also quite quick, as you see, already one done, and then the others. Perfect. No space left on the device, you see. So, and it's indeed, now I need to remove them because otherwise, let's see, rm start.grip2. So we know that 50 gigas are just the minimum. I could launch the simulation, but it was just the minimum. So if you have the opportunity, it's better to make a virtual machine of 100 gigas. So this is okay. Let me also remove, because I think there are some installation files that I can remove to free some space. Okay. And so let's go back to the website. Anyway, you have seen how to download the data. It's very easy. Okay. I mean, any single step is very easy. The problem is that when you put all of them together, you know, it's not really. Okay, I hope that the screen is clear. Now,
it is not clear again.
It is not, but I think, you know, there is no solution. And we just have to wait. I can try to share it again, but I don't think it doesn't change much. Let's try to wait a little bit.
Now it's okay. Now it's okay.
Now it's okay.
Perfect.
Just refresh and it gets better.
Okay. So basically, so we downloaded it. Now we have to move this downloaded file into the directory input data. Okay. And directory that, as you see here, you need to create beforehand into the directory bwrf. Perfect. Now we need to pre-process this data, okay, in order to bring them to their resolution global to the resolution we want for WRF. And somewhere we have to specify what is the resolution that we want with WRF. And indeed, these options that we need to select have to be specified in this file, name list.wps. This is the input option file for the preprocessor WPS. And this file is already located in this directory. It is a subdirectory of the directory build WRF. It's there. So this file needs to be edited. And in our fresh install of Linux, given that it was a minimal desktop, we don't have any text editor other than those that are embedded into Linux, which are very efficient in terms of computational resources, but are not very user-friendly. So I suggest here to install from the terminal the editor Kate, and then you can edit the file by this instruction okay? And let me just, in the virtual machine, I open it so we can see how the file looks, and I have to go under WPS 460. Okay. Now, first of all, let's first read here what we need to change in this file, and then I'll show you the results on the virtual machine. There is a detailed explanation of the options in this link, but let's forget it, okay? Because we don't need to know each of them, and we only need at this stage to know what we have to change. Perfect. So first, the start date and end date. And in the file, there are two lines named as you see here. And therefore, I put September 1st, 2025 at midnight as a start date, September 1st, 2025 at 6 p.m. end date. Very good. So be careful. We need to set dates that correspond to the timing of a downloaded initialization files. So we downloaded 4 files for 12 a.m., 12 p.m., 6 p.m. And then these are our start dates. I could use a start date that is later than that, but earlier than the end date. The end date cannot be later than 6 p.m. on September 1st. If I want to make it longer, I need to download more initialization data. Just keep it in mind. You need the boundary conditions for all the duration of the simulation. Okay, so the time interval corresponds, let me make an edit here. The time interval corresponds to the number of seconds, because the time interval has to be specified in the file, and we need to specify the number of seconds included in the time step of 6 hours. Another spelling error which I'm correcting. Okay, regarding the coordinates to include in the file under the GeoGrid section, what are these coordinates? The coordinates of the domain. You need to give the coordinates that you need to tell the preprocessor what is your domain. So where is the region where you want to simulate, and you have to give this detail in terms of coordinates. Good. Now, how to know the coordinates? Fortunately, there is a very nice tool available here, linked. Let's open it. Okay. And this is WRF Domain Wizard. I hope you can see it clearly. And basically, let's suppose that I want a domain over Bologna. Let's make it new, okay, a new domain, okay? And then let's make a zoom around here, more or less, okay? And let me just increase, sorry, I first needed to move it, probably. Let me see. Oh, okay, I can move it. Very good. So let's increase the zoom. This is even too large for us. This is not exactly the domain that I set in my file, but you can resize it, okay? You can resize, and here it is something like this that I did, something like this. I remember that the delta of the Po River was included, so probably it's something like this, okay? And then you see on the left all the information that you need for the input file. And you can also edit it. So if you just click over edit, you see this is how your name list input looks like, and you can make a cut and paste. Be careful, here there is the resolution. So I didn't try to change this resolution, but in principle you can change it, okay? Because this is a default. And of course, the finer the resolution, the longer the computational time. I don't remember if I used 12 or 15,000, which means 12 or 15 kilometers. And but I am curious. I will try to try a lower resolution. For some reason, I cannot change it here. But anyway, it's not a problem. You can change it in the file. Okay, so basically this domain analyzer, this is a window to close. This domain analyzer, close, it's a very nice tool. Now let's have a look at, let's close it, and let's have a look at the file. And it is, here there is the setting that I used. Here there is the X, the Y, 5,000, but I don't think I used 5,000 at the end of the story. So I will check and then I will edit, because I want to put here something that is for sure working. And so this is the geographical part session. Now, before we are now ready to run WPS, but before doing that, let's have a look at the file in the virtual machine. Okay, so let me just share the other screen. So here we are. Okay, sorry, it's I need the screensaver. It's better with a virtual machine. It's better to deactivate the screensaver. Actually, I deactivated it, but still, I don't know for what reason when I change the screen. Okay, so let's look at the file. So this is my directory WPS460, and here there must be name list WPS. It's this one. I open it with Kate. And here you see start date, end date, interval seconds, and this is, I'm not sure, this is, yeah, 21,600, yes. And here you see the domain and the resolution. It is indeed 15 kilometers. So let me change it here, because I want to, in the website, something, as I said, that works for sure. And then here there is the data that I got from the domain analyzer. One thing which is important to say, you see here the option max domain. I used only one domain, so it means that I have to give the coordinates of only one region. WRF is conceived for making nested simulations. What does this mean? It means that the suggestion by them is, in case you want to pass to a very fine resolution, like 1 kilometer, make two simulations. A coarser one, like 15 kilometers, like in this case, and a second one which is nested. And the nested domain can be also be smaller than the large domain. If you make a nested simulation, you have to specify two domains here. So you have to put two. And as a consequence, you have to give not only one value for instance, the start date, but two values, because if you put max domain 2, the program will search for data for the first domain and data for the second domain. And for instance, the coordinates, you have to give two coordinates, 2 plus 2. And the start date is same thing, two start dates, which can be the same for the two domains, but can be different. And if you want to see an example of a file that can be applied for two domains or other cases, there is plenty of documentation in the website, and I will show you where to find it with examples that are given like the one that I'm giving here. Okay. In this case, you see that I put only one option because I have only one domain, so only one start date because I have only one domain. Very good. Now, this is the file, so it is quite simple. Most of there are several things that you don't need to modify. And for instance, WRF core, there are other options, but you don't have to. I don't suggest to take into account other options. Max domain, yes, if you could modify it. The date, of course, you have to modify it. Interval seconds. But for instance, here, parent ID, I didn't modify anything. Parent grid ratio, and I think I wrote in my website what I modified and what not. Okay, so I wrote what you need to modify and what are the options that you can leave as default. Now we are ready to run the preprocessor. We can run it because it is very easy to run it. So let me expand the terminal, okay, or I think we can do something like this. Okay, let me expand it. And let me increase the font a little bit. Because this one, I think it is nice to, just a second. Terminal, I don't, let me see, preferences. It should be somewhere here, but not here. Appearance and default geometry. Okay, let's keep it in this resolution. I think on the screen you can see it. Let me clear it. Okay. And so what are the instructions? They are reported on the website, which you don't see now, but I can see it. So let me just have a look, and then I don't make cut and paste, but okay, we are already in the directory. First thing, we have to run this program with this instruction, /geogrid.exe. Okay, and see, it is running. You see successful completion. Perfect. We are done. And then there are other instructions to run because I give you only just the following one. The following instruction is a link. I have to link the output that has been produced with this program to the directory input data, and therefore the instruction, which is reported on my website, is link grib.gsh input data star. Okay. So I linked it. So now it is accessible in the input data directory. Okay. Let me go back to my screen because we don't need to simulate everything here. Let's see. And these are the instructions. So I went up to here, and then there are other instructions, and now we are ready. Just check that you get at the end a message like success for GeoGrid, and we saw on the terminal that we got it, and also ungrib. Ungrib gives a message of success. Here, there is no message at the end of MapGrid unless you get an error. Okay. Now we are ready to run WRF. So we are almost there. Okay.
It is
yeah.
again not here.
How it is now?
No.
It is because I need to share, and the share is refreshing is not enough. Let's try again.
No. Yes,
no.
it is. Okay.
Okay. So now, in order to run WRF, I need to give the options in another file, which is called name list input, to provide my option. And then there is a description here of the parameters. So I need to specify the length of the run. I will show you the file later on. This is just a description of what you have to change. So in this example, we are running the simulation for 18 hours. So let's run hours equal 18 and days, minutes, seconds to 0. Okay. Now we have to put start and then here month, day, like in the previous file. We have to use, and of course, you have to use, I think you have to use the same dates. Maybe it runs also if you put a date that is a simulation period that is smaller. For sure, it doesn't run if it is larger. The interval in seconds, okay. The time step, and here it's there is a note. There are some constraints on the time step, and then the max value is given by this condition. So you take the spatial resolution in kilometers and you multiply by 6. So in our case, we set the x and the y 15,000, not 5, I am correcting. And so we set time step equal 90. Okay, I am correcting now. Just 1 second. Okay, 15 time step equal 90. Okay, good. And then we need to specify the domain as in the previous file. Okay. Now we need to copy these files, met am star. These files were created by the preprocessor, and they sit into the directory of the preprocessor. We have to put them into the directory run of the WRF. Just 1 second. By VPS. In the directory, I want to specify the name of the directories. The directory VPS 460 into the directory, the subdirectory run of the directory WRF 4.6.0 with a file manager. Okay, and so you see here the instruction copy, and in this case is yeah, of course, Om Alberto and let me put users. Okay, build WRF WPS 460 in the directory WRF. Okay, this is 461. I understand. 460 is the version of WPS, and the version of the WRF is 461. Perfect. Okay, directory WRF 461. Perfect. I take some time because I am editing the web page. And then we have to run these two commands. And then WRF is executed. And it may happen that you get errors. Okay. And let me just give an example, because now you have all the information that you need to run the simulation. And therefore, I think we can move to the virtual machine and to show you what happened, how you can check if the simulation went fine. I can check it because I already did it. So we don't have to launch again the simulation. And then after this final visit to the virtual machine, we make the break. And then we have only to talk about visualization of the results. But at this stage, after running this wrf.exe, we have done the simulation. It's completed. Now we have to look at the results, but this is the fun part of the story. And the boring part, the simulation, is completed. But let me just go to the virtual machine now, and if you give me a couple of minutes, I'll show you. So let's share the virtual machine. Okay, good. This is the terminal. I prefer to reduce the terminal now because I want to open with Kate the file input for WRF. So I go to the file manager. In the directory WRF, I go into run, and then there is somewhere here the input file, namelist.input. I open it with Kate, and this is the file. So here you see run days, hours, minutes. I put only 18 hours. And then the start year, start month, start day. Unfortunately, it's a different format with respect to namelist.wps, but you know, we have to take what is available. And then there are many other options which I didn't modify. Okay, and it is described in the web page what you need to modify and what I left as default. Just note that the domain is again one, otherwise you need to give 2 columns of options. And here you have some other parameters, and for most of them I found an hard time to understand their meaning. For some of them, they are taken from this one. These ones are given by the domain analyzer, and they are reported also in the other input file for WPS. So you just have to take them. But at the end of the story, what I did was, let's try. So when I thought I was done, let's try, okay? And then I went to the terminal, okay? And I tried to run it by following the instructions that are on the website. Let me just get them back. I go back in the histories here. Okay, very good. This is actually a real exe. Yes, this is the first one. Now, you remember that to run WRF, I have to launch 2 programs. The first one is real-exe, okay? So I tried to launch real-exe, and let's see. It's not an executable, because I'm not in the right directory. I have to go into run. This is WPS, so let me see. I have to go in build WRF and then WRF run. Good. Now let's launch again the real-exe. And it seems that everything was fine, but we need to check it. Okay, and we can check it. There is an instruction which is reported in the website. Let me just get it. I go back in my history to get it. This is still early. Let me see. Still early. Here it is. This is the instruction. Tail RSL error. And you see the last line. Success complete. So it's okay. If you see success, it's okay. Let's now try to make a wrong specification of parameters in this file. So let's, for instance, change the interval second and put it wrong. like 21,200. And let's see what happens. So I clear the screen, abort, and it is not clear what went wrong here. But if you make the check, then it's clear. It says somewhere, no average, let's see, tail errors, forcing artificial timing, fatal cold. No, it says bad date in name list or file not in directory. So it doesn't say really that I made the time step wrong. So when I made this mistake, because I repeated the mistake that I actually did, it was for me a bit hard to understand what was wrong. At the end of the story, I understood what was wrong. Look here, error opening, met AM 5.53. Okay, so I said, oh, yeah, 5:53. It's wrong because I have 6 p.m. I have the meteorology at 6 p.m. And then I understood I made it wrong the time step, you know. But let's make another example. Like another problem that I had was with this parameter, which I don't know what it means. And it was originally set at 15. So let's try to launch it again. I clear the screen. So there is an error. Let's check. And increase the lowest eta thickness. It said you need one of 4 things. More eta levels evert. This was the solution that I adopted. I said, okay, let's try. I didn't check the other solutions. So I said, okay, let's try. So let's put the value to first I tried 80, again an error, and then I tried 200. And then if you run again, now it's successful. So, I mean, there is indeed a good support to the user, and now you see success. There is indeed a good support to the user. The same for the simulation, the second program, the second executable, which, however, took like half an hour for this simulation. But you could try here, for instance, and let's try it, and then I leave you free. We could try to put only 2 hours, run hours, 2, or let's say 1, okay? And so now end hour is 1:01. Let's see how long it takes, okay? And if it takes longer, we close the call, and then when we come back, it is there. But let's try, and sorry, I don't remember. I think it is just, the instruction is just wrf.exe, but I want to get it. You see that I made many rounds before, many attempts before. Okay, let me try, because I think I remember it. It is WRF something. Let me see. Okay, it is this one. Let's try it. It started, and let's try to wait 10 seconds. It's already gone. You see, for 1 hour, it was very quick. Okay, now we can check. Again, with the same instruction. Perfect. Success. We are done. And we ran our own climate model. Now we have to visualize the results. So I took 10 minutes more. Let's meet at 2:10 and after your break. Do you have any question before we close this call?
No, thank you, Professor.
Okay. I hope you enjoyed it, but we will discuss about your appreciation or not at the end of the second lecture today. Thank you very much, and let's meet at 2:10. Okay.
Okay. See you.
Thank you.